everyone, welcome to the video lecture series on Chemical Engineering Thermodynamics 1. Myself Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. In this video lecture, we will talk about various state of system such as a steady state system and equilibrium state of system. Then we will talk about intensive property and extensive property, and then we will talk about various types of thermodynamic processes such as a isothermal process, isobaric process, isochoric process and adiabatic process. So let's start with state of system. In thermodynamics, a state of system is a condition at a specific time that is fully identified by the value of suitable set of parameter known as a state variable, state parameter or thermodynamic variable. So state of system is a defined specific temperature, pressure and volume at specific time, and it's defined various thermodynamic property at specific time. To understand this, let's take one example. Let's consider piston cylinder. At this condition, this system has state 1, which is a 1 atmospheric pressure and 300 Kelvin temperature. If applying pressure on this system, then it change state from state 1 to state 2. At state 2, pressure becomes 2 atmosphere and change in volume at constant temperature. So any state of system can define by using various thermodynamic property, state variable and state parameter. There are mainly two types of state of system, such as a equilibrium state of system and steady state of system. So let's talk about steady state of system. The property and composition at any point within the system are independent of time, then that type of system is known as a steady state system. To understand this, let's consider this system at time t is equal to 0 minute. Now if going to measure property at this point and get temperature 25 degrees Celsius and pressure 1 atmosphere, and going to measure property at this point and get temperature 40 degrees Celsius and pressure at 3 atmosphere, and going to measure property after 15 minutes of same system and get same property at same location, then can say that this system are in steady state. In steady state, point to point property may change, but it not change with change in time. Now let's talk about equilibrium state. Equilibrium state, if property throughout the system are uniform and do not change with change in time, then that type of state of system is known as the equilibrium state. To understand this, let's consider a system at time t is equal to 0 minute. Now going to measure property at this point and get temperature 25 degrees Celsius and pressure 1 atmosphere. Now if going to measure property at this point, we'll get temperature 25 degrees Celsius and pressure 1 atmosphere. Now going to measure property at any point of this system and get same temperature and same pressure at every point of system, and going to measure property after 15 minutes at every point of system and get same temperature and same property, then can say that the system are in equilibrium. In equilibrium, property throughout the system are uniform and not change with change in time. There are various types of equilibrium such as a thermal equilibrium, mechanical equilibrium, chemical equilibrium and chemical reaction equilibrium and thermodynamic equilibrium. So let's talk about thermal equilibrium. In thermal equilibrium, temperature is constant throughout the system and don't change with change in time, then that type of system is known as a thermal equilibrium. To understand this, let's consider a system at time t is equal to 0 minute and going to measure temperature of this system at this point, we'll get temperature 25 degrees Celsius. Now going to measure temperature at different point and get same temperature. Going to measure temperature at any point of this system and get same temperature, and this temperature is not changed with change in time, then can say that this system are in thermally equilibrium. To understand this, let's take one more example. Let's take these two bars. One bar at 90 degrees Celsius and second bar is 10 degrees Celsius. When these two bars are connected with each other, they trying to change temperature and try to equilibrium. So both bars are trying to reach equilibrium state. After some time, both bars are at equilibrium at 50 degrees Celsius. So can say that these bars are in thermally equilibrium. Now let's talk about mechanical equilibrium. Pressure is constant throughout the system and does not change with change in time. Then that type of system is known as a mechanical equilibrium. For example, let's consider this system at time t is equal to 0 minute and going to measure pressure at this point will get 5 atmospheric pressure. Now if going to measure pressure at this point and get same 5 atmospheric pressure. If going to measure pressure any point of this system and get same pressure and this pressure not change with change in time, then that type of state of system is known as a mechanical equilibrium. To understand this, let's consider a system. In this system, there is a wall between these two systems. At right hand side 0 atmospheric pressure and at left hand side there is a 2 atmospheric pressure. Now if going to open this wall, this system going to be reached in equilibrium by 1 atmospheric pressure. So this type of equilibrium is known as a mechanical equilibrium. Now let's talk about chemical equilibrium. Chemical potential is a constant throughout the system and does not change with change in time. Then that type of system is in chemical equilibrium. For example, let's considering this system and going to measure chemical potential at this point and get chemical potential 5 joule per mole. Now going to measure again chemical potential at this point, get 5 joule per mole chemical potential and going to measure chemical potential after 15 minutes and get same chemical potential throughout its system, then can say that this system are in chemical equilibrium. For example, let's consider this system. Let's consider there is a solute and solvent. When the solute is mixed in solvent, this all solute are dissolved in solvent and make chemical equilibrium state. Now let's talk about chemical reaction equilibrium. In reaction, forward direction and backward direction rate of reaction is same, then that type of reaction is known as a chemical reaction in equilibrium. To understand this, let's consider a chemical reaction in which reactant is A plus B gives C plus D. So forward direction rate and backward direction rate are same in this reaction, then that type of reaction is known as a chemical reaction equilibrium. Now let's talk about thermodynamic equilibrium. If system is in thermal equilibrium, mechanical equilibrium and chemical equilibrium, then that type of equilibrium is known as a thermodynamic equilibrium. To understand this, let's consider this system. This system is in chemical equilibrium, thermal equilibrium, mechanical equilibrium. Now again going to measure property of this system after 15 minutes and get same equilibrium, then can say that this system are in thermodynamic equilibrium. So any system which are in chemical equilibrium, thermal equilibrium and mechanical equilibrium, then that type of system are considered in thermodynamic equilibrium. Now let's talk about intensive property. Intensive property are bulk property or they do not depend on amount of matter that is present. To understand this, let's consider this bar at 25 degrees Celsius temperature. Now if going to break this bar, so divided in two parts. In one part again temperature is 25 degrees Celsius and second part temperature is 25 degrees Celsius. So if going to break this bar, property of this bar is not changed after breaking this bar, then this type of property which not depend on amount of matter, then that type of property is known as a intensive property. Now let's talk about extensive property. Extensive property are dependent amount of matter that is present. Let's consider this bar which length is 1 meter. Now if going to break this bar, then it's convert in two part. In one part, length of this bar becomes 0.25 meter, and second part, length becomes 0.75 meter. So after breaking this part, this bar has changed their length. In previous example, temperature is not going to change while breaking this bar, but in this example, when going to break this bar, there is a change in length. So length is a depend on mass. So mass and length and volume are the one type of extensive property. So volume, mass, size, weight and length are example of extensive property. Now let's talk about process. To understand this, let's consider a system. Any change in system is known as a process. This change may be a chemical or this change may be a physical. So any change take place within a system is known as a process. There are various types of process, such as a isothermal process, isobaric process, isochoric process and adiabatic process. In isothermal process, temperature is a constant, wherein isobaric process, pressure is a constant. In isochoric process, volume is a constant, and in adiabatic process, heat is a constant throughout the process. So these all are types of process. There are various other types of process which we'll discuss in other lecture. So I am completing my lecture here. Thank you.